Welcome to our Oilfield Water Services Field Case Study series. My name is Ross McCartney, and in this series I'll be showing you field examples of how produced water analyses can be used to benefit scale, water, well and reservoir management. For all these case studies, where they have been published, the reference for the work is given at the end of the presentation. In this presentation, you'll learn how produced water analyses were used to identify the source of formation water being produced from a water-washed well, and how this aided a decision to turn off the water wash system, resulting in significant cost savings for the asset. The study was undertaken on the Heron field in the North Sea by Webb and Kuhn. This field has 4 production wells. This figure shows the formation water analyses obtained from residual salt analysis of core samples. The depth profiles show that with greater depth there is an increase in formation water salinity and strontium isotope ratios, and this is accompanied by a decrease in formation water sodium over chloride and magnesium over calcium ratios. The samples were obtained both from the oil leg and the underlying aquifer. The lowest salinity formation water is present in the shallower section of the oil leg, and the highest salinity formation water is present in the deepest section of the oil leg and in the underlying aquifer. The highest salinity of the aquifer formation water was also confirmed via water samples collected from appraisal wells. Using these formation water analyses, it was predicted that when the field started production, if the high salinity aquifer water were to be produced, this would cause halite scale deposition in the wells. So, to mitigate this scale risk, it was planned that low sulfate seawater would be injected downhole in the wells as a wash water, the idea being to dilute any formation water entering the well. But note that due to the lower salinity of the shallower oil leg formation water, if this were to be produced into the wells, there would be no halite scale risk. So once production started, produced water samples were collected and analysed. Evaluation of these analyses indicated that the produced water was a mixture of formation water, wash water and condensation water. The compositions of these samples were compared with theoretical mixtures of wash water and aquifer formation water and wash water and oil leg formation water. This comparison used iron ratios because this meant they could ignore dilution effects caused by the condensation water. The comparison was undertaken using principal component analysis, a multivariate statistical technique. The results are shown in this figure, which compares the datasets. The lines represent the theoretical mixed compositions and the solid circle symbols the produced water analyses. The figure shows that the produced water analyses are consistent with production of shallower oil leg formation water, wash water and condensation water. That is, there is no aquifer formation water production. Interestingly, the lack of aquifer formation water production was consistent with other reservoir studies, which suggested that there was a barrier to vertical flow separating the shallower and deeper oil leg. Because there was no halite scaling risk with production of formation water from the shallow oil leg, a decision was then made to turn off the wash water injection. Monitoring of the wells continued, and there was no evidence of halite scale deposition in the wells after wash water shut-off based on produced water sodium over calcium and sodium over chloride ratios, and from running drift and other tools in the wells. So what were the benefits of interpreting produced water analyses in this case? Well, firstly, oil production increased due to the lower water cut. Also, there were reduced operational costs because it was not necessary now to operate the wash water facility on a daily basis, and nor was it necessary to remove and reinstall the wash water lines each time there was a well intervention, and this saved rig time. Scale management of these wells was simplified because no halite mitigation was required, and by supporting the presence of a barrier to vertical flow in the oil leg, this allowed the reservoir model to be modified with more confidence. So again, use of produced water analyses allowed very beneficial decisions to be made without the need for any well interventions. I hope this brief presentation has given you a greater insight into the value of produced water analyses. If you require further information, please visit our website at www.oilfieldwaterservices.co.uk, where you will find our extensive publication list, which cover many field cases. You can also contact me via my email on ross@oilfieldwaterservices.co.uk. Don't forget to subscribe if you want to see more videos from us on the uses of produced water and formation water analyses in the oil industry. Thank you for your attention, and I hope that we can be of service to you soon.